Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 8. Haunted Wasteland. You're still riding a camel across desert island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled maps. Sure enough, there is full of documents. Your puzzle input about how to navigate the desert. At least you're pretty sure that's what they are. None of the documents contain any list of left-right instructions, and the rest of the document seems to describe some kind of network of labeled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instruction, you can escape the haunted wasteland. After examining the maps for a bit, two nodes stick out to you, AAA and ZZZZ. It feels like AAA is where you are now, and you to follow the left-right instructions until you reach ZZZ. This format describes each node of the network individually. For example, RL, AAA. Okay. Starting with AAA, you need to look up the next element based on the next left-right instruction in your input. In this example, you start at AAA, go right to choose the right element of AAA, CCC. Then L means to choose the left element of CCC. By following left-right instructions, you reach ZZZ in 2 steps. Of course, you might not find ZZZ right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. Left, right, LR, 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 and so on. For example, here is a situation where it takes 6 steps to reach ZZZ, LR, LLR. Okay. Starting at A, follow the left-right instructions. How many steps are required to reach Z? And branch has a private branch left and private branch right. And the public branch string description we have here. And go back to the descriptions here. So this is one description there. So to parse this, we need first of, we could actually do a pattern. Pattern compile. Let's see here. So this should be parentheses, 3 words. Like that. And then space, and then we have a parenthesis. And the same goes again. Same goes again, and we end with a parenthesis. If we do like that, private string left string private that. So then we should be able to take the same logic that we had down here and then put in, can also have the string name here. All these should be final. Name is equal to the first group. Left is equal to the next group. And right is equal to the last group. We should find them, we should set them. And we should use this description instead. Then we can take a public update map. And here we have a map with string branch. Get left string, and that we put into left. The same goes for right string. Put that into right. Like that. And it's a void function. String branch. Map. Hash map. Map. And map. New branch line. Like that. And we need to put branch get name branch like that. Couldn't you figure that one out? Yeah, there we go. So now we have a map, and we need to go to for each branch in map values be update map with map. Do like that. Yes, because we haven't removed the first line here. Let's see. Let's go to our text. Oh, can do string command. So if command is equal to null, then command is equal to line, continue, and if line is blank, continue. That should work things out. for string command. So we will need to go through the command and split it into characters. And here we need to do a switch statement. If switch on C, if it's the right, we do this and then break. And then we could have a left and then break. And these are two cases. Branch current map gets AA. Current get right. Here we do current get left. If current get name equals ZZ, then we're done. Iterations 0. Like that, perhaps. If we run that. Get here. We haven't implemented these. So if we go back here and run it, we get here. So now we're currently working. Actually work here. So if we run that, we should get 2 steps. Like that. Yes. And if we copy the next example here, we get 6 steps. Okay, so it seems to work. Let's try it with the large example here. $12,169. So let's try that. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. Let's go into part 2. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. The sandstorm is upon you and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you're barely left at your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? The ghosts are not even bound by the laws of space-time. Only one way to find out. After examining the maps a bit longer, your attention is drawn to the curious fact that the number of nodes with names ending with A is equal to the number of ending with Z. If you were a ghost, you probably just start at every node that ends with A and follow all the paths that at the same time until they are simultaneously end up at Z. Here are two starting nodes, AA 111A and 222A, because they're both with A. As you follow each left-right instruction, you use that instruction to simultaneously navigate away from both nodes you are currently on. Repeat this process until all the nodes you are currently on end with Z. If only one of the nodes you are end on with Z, then act like the other node, you continue as normal. In this example, you would proceed as follow. So I think I'm just gonna do the absolute simplest solution here. So let's get that back here. And I'm gonna have a list of branches. Current list. Array lists. And here we go through. Up here we update the map. And during that update we can also check get name ends with A. So if that is the case, then our current list is gonna add that particular branch. And then here we will create another for loop branch current current list like that. This is our current. Like that. And here we can say also if int found 0. So if current name ends with Z, then found plus plus. So there we found another that ends with Z. And down here, if found is equal to current list size, break, working false. And we still have iterations up here, so that's correct. Then we need to have a new branching list here. New list. We add to that list. So here we have a current list equals to new list, and then new list is just an array list. This seems strange to switch over to new list and then go back. It's the fastest way. I'm sorry. Let's see. If we now go like this. No, we need to have current here. So we change the current. So here we have branch work current. So then we will just switch the pointer here of this working node. And then down here we will have new list add work, because that is the new place. So that's not correct. So when we have run through all of these, we have done command length command. It's a little bit irritating. Like that. Number iteration. Then we get 8 iterations. Why do we get 8 iterations? Wait a minute. We should check the name of work, of course. Yeah, now we got 6. So this is not a good solution for this, but it is a solution. It might take forever to run, but let's try it. See what happens. Haven't even checked what this input contains. Oh my god. A lot of left and right. Yeah, this will take a while. Well. That took a while. I actually added something that typed out every billion try, which was required because it was several billion. And I also did a couple of more improvements here, but I think we will try this first. If it's correct, we will go through the code. So let's switch over here, put it in, and see. Yes! You get a gold star! I get a gold star! Everybody gets a gold star! So, what did we do? There were a bunch of things that I did to make this faster. So first off, we had this thing here where we created the branches. So we went through and put in a line to a branch class and then put that into a map. So we had all the different branching. And the branch class is pretty much something which have a right and a left. It has a name. And then we had a right and a left string. I also added this ends with a Z. So we actually have that boolean there. Much better for finding out if it ends with a Z. We also have the next branching, that is, if we have gone through all the commands, what is the next we end up in. So when we actually parse through here, we will put the description in here, run it through this pattern. We get the name, left string, right string out, and then we could check the name against if it ends with a Z. To update the map, we just go through here, check the left string, right string, take them out from the map and put them into left and right. We could get the name, we could get the left and the right back, and we could also get the next that we find, the next branching. We set it and get it, and we can also check the Z. So in day 8 here, what we pretty much did after we had listed these through, we went through and checked through these, created a current list, what we want to work with, and if anything ends with an A, we put it into this current list and we update all the maps. So all of the maps actually has the correct left and right. Then we go through all the branches again and figure out for this command that we split up, go through all of that and figure out what is, after one run, what is the next value that we get. So we will not run the command every time. We'll run it once, figure out what is the full path that we will go through and the next value will end up in. And we actually pick up from the map the actual class that we end up in. So we only have the class and the if this is ends with the Z. Then we have this working boolean here. We have a new list that's to the current list, so we actually could start the iterations. We have a long, which is the iterations. We have a value here that I just add a billion to in order to use it to print out stuff. Then we need to figure out how many we have found, how many of these different paths have actually found its way to an ending Z. We set the current list to new list. We clear out the new list. Then we will go through all the branches and find the next value for this branch, so the full path. And if the next ends with the Z, we have found one more, and then we will add it to the new list. And if this found value is the same as the current list size down here, then we will not be required to work anymore because we have the number of iterations. Then we will take the command length, so all the different left, right that we do, and put that into iterations. So we will increase the iterations with the length of the command because we run the full command every time. And if the iterations is larger than this value, print it out and then add another billion. So that's why we got this huge list of pretty much a step of a billion between each. So up here we got this value that we printed out down here, and it was the right value! It took a while, but we could figure it out. So this was today's video. I hope you like this video. If you want to show your solution in the comment section down below, I read all of them. If you have any comments or suggestions, leave them down there as well. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.